I've seen hundreds of Loxone projects, and one thing that is very common across all of them is that digital inputs are simply not being used. Now, when it comes to digital inputs, that is probably one of the easiest and cheapest ways by far to add additional functionality to the project without necessarily skyrocketing the cost of the whole installation. So first of all, what are they and how are we going to use them? Right, so I'm pretty sure that every single one of you have seen something like this, a very, very basic switch. Now, this is going to be a digital input. Basically, any single device that can give us a signal, that can be a motion sensor, a switch like this one, a water contact, a window contact, and so on, can become a digital input. It's basically just a 1 and a 0, and it's just a contact that is shorting on the back end. If you do want to convert a very basic switch, that's probably going to be the best and easiest example. To the common, you supply 24 volts instead of mains, as you usually do. And then on the switch live, you go back to the mini server. And as soon as the two contacts close, you are going to get a signal back into the system. Now, to make this even easier and simpler to understand, I've actually made a little video. And everything that you can see in here, basically all the oranges are 24 volts plus coming from one power supply. If you do have multiple power supplies, make sure you comment them. But basically, if you go and put just a wire on digital input and grab a positive from the same power supply, you short the two against each other, you can see the signal is coming through Loxone. You can also click on your mini server if you have live view on. You can see these little dots, little circles, the green ones, and you can basically troubleshoot very quickly if something is coming through, if that signal is being opened and closed. When it comes to Nano IO, it's great for some other scenarios where you want to decentralize the digital input. You can put it in the ceiling somewhere close to the installation, and then that way you don't have to pull multiple cables back to that panel. And then they all work pretty much exactly the same way. You can see a window contact being open and closed, and then a signal coming through. You can see a thermostat that is usually supposed to be 230 volt. However, if you just grab a multimeter and put your in test for continuity whenever it opens and closes, you know that you can pretty much apply it with whatever you want for the signal. What you can see in there is also a tiny motion sensor, and then that tiny motion sensor is actually an open collector, which means that it doesn't short to positive, it shorts to ground. And because of that, I have a resistor in between the positive and the negative, and then the negative or the ground is actually coming back into a digital input. What we can see is that it also triggers on and off. However, again, because it's an open collector, I have inverted it in the logic. So on is, well, off is on and on is off. There's something else that you probably have seen in a previous video or a short. We have a non-contact water level sensor, and you can pretty much see what it does. It connects to a Nano DI in this case, but it works the same way on a mini server. And one of my favorite use cases is definitely going to be the SO output, or S0 output, sorry, which is basically just a signal. So on meters like this energy meter or a water meter and so on, every 100 pulses or every 1000 pulses are going to equate to something. In this case, every 1000 pulses equates at 1 kilowatt hour. And you can see that as soon as I plug in my higher load, in this case the iron, it starts pulsing in the back end. And if you look at the screen, you can see 2.25 kilowatts, and then the system is already registering exactly 2.25 kilowatts. So they maybe not be as accurate as doing it via Modbus, but significantly easier, and you can see it in here pulsing away and still adjusting that value. Depending on the pulse duration, the pulse meter function block itself automatically decides what it needs to do. And then definitely one of my favorite use cases, you can see that the magic cup is coming in. If you want to do the cheapest sensor possible, just a water contact, you can just have two bare cores on the ground. As soon as there's water across of them and they obviously make contact, they short out, the signal is going to close. And in the Loxone app, if you have a water alarm, it's going to trigger the alarm, it's going to send you a notification, and then you can go and see what's actually happening. This is pretty much for free because I assume that your mini server is going to be in the panel, is going to be in that central location. So you might as well just run a small cable to it. Then in terms of visualization, you can see how things look in the app. You can see the energy meter, you can see the water level contact, you can see the heating demand and so on. Once we get that signal into config, we can really decide what we want to do with it, and the options are pretty much limitless. You can monitor for burglar alarm, you can switch off the heating system, or you can do pretty much anything else. If you do just want to visualize two wires, of course you can, a bit redundant however. And then last but not least, again, here's a signal being triggered. Nice and easy, very, very simple, but it can save you a lot of money in the long run. So, long story short, digital inputs are a very, very powerful tool. I would say that pretty much everything that you're seeing in there, besides the meter, is under 30, 40 pounds. Most of them are probably under 5 or 10 pounds in the first place. So, very, very cheap sensors. They're not going to throw off the budget, and you add a lot of functionality in space. The only one that I didn't show in here is the fact that a digital input can be used as a frequency meter. I didn't have a frequency sensor, surprising enough, at home, but I have plenty of other proximity sensors, conductive sensors, and so on. All of them work very, very nicely, and it's pretty much exactly the same logic throughout. You can use it also on wireless things, like the Nano IO, and then you can utilize it. It has 6 digital inputs on the other side. So again, it is already in there. We might as well use it. That's going to be pretty much all for me. I would love to know what kind of sensors you guys use in every single project, or what sensors you like to utilize in your installations. And if there's something that I miss, by all means, just drop down a comment and let me know. Cheers, guys, and see you in the next one.